In this segment, we describe position versus time graphs. Remember, position gives us the location at any time. It gives it in terms of a distance and a direction. And remember that a displacement is actually a change in position. Now, if we have something moving horizontally, we can use X for a label of the position, or P. Let me go to just writing P as a function of time. Now, let's try to think of an example to try to explain what we have here. Let's assume we have a person who for 2 seconds stayed two meters north of our reference, whatever is our reference. So for 2 seconds, the person stayed 2 meters north of our reference. Then that person took a second to move to a position 3 meters south of the reference. And stayed there. Okay. Let's try to graph that here. Now, if we use these ticks as meters, so this is 1 meter, this is 2 meters, 3 meters, and minus 1 meter, minus 2 meters, minus 3 meters. We set this as our origin, which is our reference point. Now, if we choose north to be positive and south to be negative, then the first 2 seconds, so let's set this as seconds. The tick is 1 second, 2 seconds, 3 seconds, 4 seconds, and 5 seconds. Now, here they tell us that the person stood at the position of 2 meters north, so it's this position, for 2 seconds. So for 2 seconds, stayed at that position. And then it took 1 second to move where? 3 meters south of the reference. So after 3 seconds, this person is going to be here. And it took this 1 second to move here from here to here. They didn't tell us how that person moved, so we are going to just join this somewhat like this. Okay? So this is a position versus time graph. When I look at a graph like this, I can determine the position at any of these times. For example, if someone tells me, where was that person at t, at time t equal 4.5 seconds? And I come here, 4.5 seconds, so at minus 3 meters, or 3 meters south of the reference. Where was the person at 2.1 seconds? Okay, there we have to do some approximation. 2.1 is probably here. We are going to say the person was about 1.8 meters north. So the bottom line is, in a position versus time graph, we are going to be able to read off the position by just looking at the graph. If we are asked to find a displacement, then we have to record two positions and then figure out the displacement by calculating it like in the previous segment. For example, what is the displacement of the person between t equal 1 second and t equal 4 seconds? T at position at 1 second, P initial is in this case 2 meters. Position at 4 seconds, position final, is minus 3 meters. So displacement is minus 3 meters, minus 2 meters. So it is actually, our displacement is actually minus 5 meters. Okay, let's look at another example. Okay, we have a graph here, some random graph. Again, remember, it gives us the position at any time. Okay, we are adding this part here, we'll discuss in 1 second. Actually, we will not discuss it at this stage, we'll discuss it later on. We didn't cover velocity yet. Sorry about that, I didn't realize it's remained in the slide. Okay, anyway. So what's the position at t equal 3 seconds? So we look, this is 4 seconds, this is 3 seconds. There's our position at x 3 seconds. It is 1 meter plus 1. What is the displacement between t equal to 5 and t equal 1? Okay, now at t equal 1, the position is plus 2. At t equal 5, this is 5, the position is plus 1. So my displacement is plus 1 minus 2, which is minus 1 meter. Now, one thing that is important here, when we talk about displacement, all what matters is initial position and final position. It does not matter how you get there. All what matters, initial and final. That's what the displacement is. It does not matter if you went to it straight or you went all the way around to get there. Like in this particular case, this person went further away, closer, then further away again, and then closer to move this 1 meter, to have a displacement of minus 1 meter. The actual distance traveled is much different than that.